All right, for those people that are actually paying attention, so class.
Yes.
Ooh, thank you. All right. So we're gonna go through, and I know everyone actually has their calculator with them because good students bring their calculator every day. Right? So calculator's out, so we could actually show this. And x minus 2 to the 4/5. Now, a little bit of review. The 4/5 is a fractional exponent. The 4, the top number, is going to be the exponential, and the 5, the bottom number, is the root. So it's going to be the 5th root taken to the 4th power. That's what that 4/5 mean. So I'm going to show this here. Parentheses x minus 2 close caret 4 over 5. Now, this thing right here, menu, zoom, and all right, so this thing right here, it is referred to as a cusp as it's going down. Remember, we cannot find the tangent at a point-to-point like this because from there, you can't really balance a tangent line on the end of a point. Does that make sense? So for us to actually get a tangent line somewhere in there, I should have at least a 0 that's going between the left side and the right side, something like that. But in here, it's going from a negative slope to a positive slope with no in between. So I cannot take a derivative or get a slope at that point. So this one's a cusp. Yeah.
This is like a more technical question, but how is the point, like, what is the limit of the point being pointy? You know what I mean? Like, how less pointy?
So it should go to 0. So if you think about it, trying to balance it on, like, even if it was just like a corner. So a corner is just 2 straight lines going to that right there, and that, for those people watching online, my hands are together showing a point. So the corner, like a 90-degree corner, I still can't get a point or a tangent line to balance on that and still get an equation for that. Does that make sense?
So it has to just be rounded?
Somewhat. It has to actually transition. These are not transition. Yeah.
And then, like,
yeah. So there's got to be a transition in between the two, but there is no transition here. It's a jump from one to the other.
It's almost like it gets so sharp to the point where it's like one line, and then by that point to balance it, you like perpendicular.
Yeah. So right here, I could actually put where's my ruler? So for those people watching online, I have my ruler, and I'm actually putting it up here. And so if you look right here, I could actually put this, balance it on that. Wow, I'm not even touching the board. Okay, I could balance it right there anywhere on that point, and it could rock back and forth, and it could still only touch it at that single point right there. Does that make sense? No? Kind of?
Yeah.
All right. So yeah, there has to be a transition in between there. So let's see. All right, information about this from its graph. So does the graph have any horizontal tangent lines? Horizontal means left and right. Okay, does this graph have any horizontal tangent lines? If yes, where? This one? Does it? No. Okay. So what would be the slope of a horizontal tangent line? 0. The slope of a horizontal line is going to be 0. Does the graph of f have any vertical tangent lines? Yes. This one's going to be at x equals 0, isn't it? Okay, so x equals 0. So there is right there, okay, I identify what occurs, determine point is a cusp of f. It's not a cusp. This right here looks like it's going to be an asymptote as it goes all the way up to infinity there, all the way up to infinity there. A cusp would be like the previous problem like we did, where it comes into a curve and goes directly into that singular point where I cannot get a slope at that point. Does the graph have any corners? Corners would be like that right angle, like 90-degree turn, and right there at the edge, it would not there. So the difference between cusp and right angle is how it's actually going to it. As it's continuously approaching, getting sharper and sharper as they look closer and closer, would be the cusp, where a corner is just like a 90-degree corner.
So could you define like the standard line like
X approaches infinity. Is that what you said?
yeah, well, could you find the tangent line for like infinity? Like if it's an asymptote.
Oh, okay. So I
Tangent line is the same as like a horizontal asymptote.
yeah, it's approaching. The slope would be approaching 0 to that.
The tangent line of like a horizontal asymptote that was
But a tangent line, you would have an equation for that tangent line.
okay.
So you would be basically, if it was on the x-axis, it would be y equals 0, and it goes all the way across, like that. But remember, infinity is not a number, it's an idea. So we really can't find the slope at, or a tangent line, equation of a tangent line at an idea.
And then could you find like the slope of the sorry.
Go ahead.
Could you find the slope of the tangent line at like somewhere like where it jumps, like on one of those sides, could you find it?
Yeah. So in between 2 and 4?
Yeah.
Yeah, in between 2 and 4 you can.
But what if you just use like the top
Okay.
one?
But you gotta have it at, both sides.
Okay.
It's got to be continuous over both sides. So you can't have like a one-sided limit. You would have to have both sides, and it actually be continuous at that point. Yeah. Fails to explain any corners, no corners. But this one right here is going to be a jump on that one right there. All right. These are theorems. You'll probably see these maybe in the text or even in the book if you guys ever pick up the book. Most people really don't care for the book, but yeah, the book is actually pretty good if you could read it. Reading a math textbook is important, especially if you plan on going to college and taking a math class. You're going to have to read a math textbook. Yes. AP Calculus. There's a hummingbird on it. We have copies of it back there. Anyway, if a function has a derivative at a number c, then it's continuous at c. Corollary, which is the inverse of that, if a function is discontinuous at number c, then it has no derivative. So if it is, right here, looking at it backwards, function has a derivative, so if I could take a derivative, therefore it must have been continuous. But inverse of that is, if it's discontinuous, I already know that it has no derivative at that point. All right, continuous at 1, and 1 f prime of 1 exists. G is continuous at 0, but G prime of 0 does not exist. That is a corner. That's an example of a corner right there. So it is discontinuous on this next one. So since it is discontinuous, then right here, it doesn't exist anyway. There we go. Everyone's going to make sure you like, share, and subscribe, and therefore that this should be due tomorrow. because we got majority of class today to work on it.